Hello, I am Rahul Baghel, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Welcome you all to the course on Industrial Automation and Drive. Today, we begin with our 16th lecture on PLC Programming Part 3, focusing on retentive timers. In the previous lecture, we covered the T of timers. So let's start the PLC retentive timer instruction. A retentive timer accumulates the timer whenever the device receives power, and it maintains the current time should power be removed from the device. When the timer accumulates, the time equals to its preset value. The contacts of the device change states. Loss of power to the timer after reaching its preset value does not affect the state of contacts. The PLC programmed retentive on delay timer RTU is programmed in a manner similar to the non-retentive on delay timer TON, with the major exception retentive timer reset instruction, that is RES instruction. Unlike the TON timer, the RTO means retentive timer will hold its accumulated value when the timer run goes false and will continue timing when it left off when the timer run goes true again. This timer must be include a timer reset instruction to reset the accumulated value of timer to 0. The RES instruction is the only automatic means of resetting the accumulated value of a retentive timer. RES instruction has the same address as the timer. It is to reset. Whenever the RES instruction is true, both the timer accumulated value and the timer done bit are reset to 0. Let's see the program. In this case, you can see the RES instruction and the retentive timer. The timer address is T4:2 and the base value we are taking as 1 and the preset value we take 9 seconds. The address, as you can see in the diagram, in the first rung the push button 2 is connected to the reset value, and the reset value the reset output, and the reset output address is also represented by T4:2. In the similar way, you can see on the second rung the push button 1 is connected to the timer and our output is represented by PL in the third rung, and the output is connected to the timer done bit, and the timer done bit address you can see in the diagram, that is T4:2/DN in the third rung. Now see the operation of the circuit. In the first step, the timer will start to time when the push button is closed, when the first push button is closed. You can see in the first push button connected in the second rung. So when I press the push button 1, the timer is start, right? If the push button is closed for a 3 second and then the open for the 3 second, the timer accumulated value will remain at 3 seconds. When the time push button is closed, again the timer pick up the time at the 3 second and continues the timing. When the accumulated value equals to the preset value, the done bit is set to 1 and the pilot light output PL is switched on. Whenever the momentary reset push button is closed, the timer accumulated value is reset to 0, right? Again, I am explaining this procedure. See, our timer is connected to the push button 1. So when I press the push button, our timer start counting like a TON timer, right? So when I press the push button means when push button changes their states from normally open to normally close, our retentive on delay timer gets the supply and it start counting. In the same time, enable button is high, right? And after that, when the accumulated value is equals to the preset value, then our done bit is high. It's similar to the TON timer. But in this case, when the timer start counting in the between 0 to 9 seconds, suppose I close the push button 1 Means initially I start the push button, my timer start counting, but suppose after 3 seconds when I stop my push button, my timer accumulated value hold this 3 seconds, and uh, when again I press the push button 1, my accumulator start counting from the 3 second, right? That is the major difference between the T on timer and the retentive timer, right? My retentive timer hold the accumulated value, but in T on timer, if I close the supply to the timer, my timer reset to the 0. Getting my point? And you can see in the first rung, my push button 2 is connected to the reset value, and when I press the push button 2, my timer is reset. Okay? As you see in the timing diagram also, this is the timing diagram of the operation. In the timing diagram also, you can see initially all the push buttons are 0, so my output is 0, and when I press the push button 1, my timer start counting, and after 3 seconds, you can see in the timing diagram, after 3 seconds, when I close the push button 1, my timer is hold that time period. As you can see in the third line in the timer circuit, you can see the 3 second is hold, and after some time when I again start my timer, again start my push button, you can see my timer counts from the 3 second, that is 4, 5, 6, 7 and 8, right? Timing diagram you can clearly see, and after 9 second, when my accumulator value is equals to the preset value, my done bit is high and my output will become on. My output which is connected to the done bit, that is T4 colon 2 slash done bit, is become high after 9 second, right? So program is similar to the T on timer. The only difference is my retentive timer hold the accumulated value when my input supply is goes down or goes off, right? So in the diagram you can see that I'm again explaining, when the timing rung is true, PB1 closed, the timer will commence the timing. If the timing rung goes false, the timer will stop timing but recommence the timing for the stored accumulated value each time the rung goes true. When the reset PB2 is closed, the T4 colon 2 done bit is reset to 0 and turns the pilot light output off. The accumulated value is also reset and held at 0 until the reset push button is opened, right? To understand this, let's see another program, and you can see in the diagram, this is the actual programming in RS Logics. Here you can see my retentive on delay timer is connected to the normally open switch, and the address of the normally open switch is represented by I colon 0 slash 0, and the timer address is represented by T4 colon 0 with time base 1 and the preset value 10, right? So let's take the first case. In the first case, when my input is 0, means when switch is in their initial state, normally open state, that's why my timer doesn't get any supply, that's why enable bit and done bit is equals to 0. So my output, which is connected to the done bit of the timer, that is T4 colon 0 slash done bit of the timer, is also 0. As you can see in the diagram, my output address is O colon 0 slash 0, right? And the reset button, you can see in the third rung, the reset button is connected to the next input, that is I colon 0 slash 1, right? So in the first case, when the output when the input is 0, output is 0, right? Now let's take a second case. When I press the switch 1, or when I on the input, you can say my timer gets the supply So you can see in the diagram, the enable button is high, and you can see my timer start counting from 0 to 10 seconds, right? As you can clearly see in the diagram, when I press the input supply, my timer start counting and my enable bit is high. And in this case, my done bit is 0. That's why the output connected to the done bit is also 0, right? Now let's take a third case. The input is high and my timer is counting. Suppose in this case, when I make a fault condition or when I make an input goes to 0, so you can see in the diagram, the input I colon 0/0 is switch off, means it changes their state from normally closed to normally open. In this case, you can clearly see my timer accumulator value, you can see it is 6. It's not equals to 0. Means my timer hold the accumulated value, right? My timer hold the accumulated value, and in this case also my enable bit is 0 and my done bit is 0. That's why my output is 0. Getting my point? And now let's take the another case. When I again start my input, you can clearly see my timer start counting from the 6, right? Not 0. So accumulator value start counting from the 6. In this case, my enable bit is high, but in the same time, my done bit is also 0 because my accumulator value is not equals to preset value. That's why done bit is not equals to 0. That's why my output is not equals to 0, output is equals to 0, right? And after in the next case, when my accumulator value is equals to the preset value, as you can see in the diagram, when my accumulator value is equals to the preset value, my done bit is high. That's why my output connected to the done bit is also high, right? That's why my output connected to the done bit is also high. And if we want to reset our timer, then the next switch, that is in the third rung, I colon 0/1 is used to reset my timer, right? I think you understand the procedure of retentive on delay timer. The major difference between retentive on delay timer and T-on timer is the retentive on delay timer holds the accumulator value when my input supply goes off and on, right? To understand this, let's take another example. In this case, suppose we have a start switch to press output for 5 seconds, then turn off for the 5 seconds. We have a start switch and the output goes for the on for the 5 seconds and off for the 5 seconds. This processor continue when the stop button is pressed, means we have to make a Diwali light which blinks in a 5 seconds, right? The program is clear, right? The objective is clear, the program objective is clear. Yeah, let's take the solution. Yes, you can see in the diagram, one is we have two switches, that is I colon 0/0 and I colon 0/1. I colon 0/0 represented by normally open switch and I colon 0/1 is represented by normally closed switch. So I take I colon 0/0 as a start switch and I colon 0/1 as a stop switch. And in the first rung, you can see the binary output is connected in the first rung. And with the use of this binary output, I connect my output, that is O colon 0/0, and this represent the bulb, suppose. So, and in this case, you can see in the rung 3rd and rung 4, we are using two T-on timer, like the first timer address is T4 colon 0 and the second timer address is T4 colon 1. And you can see in the second rung and third rung, I am just providing the NC contact of my timer done bit. And the second rung, you can see the T4 colon 0/done bit I am using, and in the third rung, you can see T4 colon 1/done bit I am using, right? So let's take the operation step by step. In the first step, suppose when input is 0, means I'm not creating any changes in the switching conditions. So in this case, when input is 0, means I colon 0 slash 0 is equals to 0, means it is remain in their same state, means normally open state. In that case, my binary output doesn't get supply. That's why if binary output doesn't get supply, means output connected to the binary output which is shown in second rung is also 0, and the same time you can see my binary output address connected to the timer, first timer, that is T4 colon 0. That's why my timer also doesn't get any supply. That's why the enable bit and done bit of the first timer is also 0. And if the first timer enable bit and done bit is 0, the second timer is also doesn't getting any supply, because my second timer is connected to the first timer done bit, as you can see in the fourth rung. That's why my second timer done bit and enable bit is also 0. That's why you can see the interconnection of the timer in the second rung and third rung. The two switches which is represented NC contacts are also remain as in the NC conditions, right? Let's take the next case. When I press the input switch, or when I start my switch, or when I changes the input switch from normally open to normally close, as you can see in the diagram, when I press the switch, in this case my binary output becomes 0, binary output become 1, as you can see in the diagram. In the first rung, my binary output B3 colon 0 slash 0 become high, and you can see that in the second rung, when binary output is high, the switch connected to the binary output is also high. It also changes their state from normally open to normally close, as you can see in the second rung. In my second rung is also the B3 colon 0 is high, and next switch is already normally closed switch of the first timer done bit. So in the second rung, my output is also high. You are getting my point? When I press the input switch, my binary output become high, and when the binary output become high, my output will become high. In the same time, you can see my timer is start counting, because my binary input, my binary output is connected to the input for the first timer. So my timer is getting supply. That's why my first timer is start counting for the 5 second. Getting my point? So my bulb, as you can see, the bulb that is output O colon 0 slash 1 is on for the 5 second, right? After 5 second, you can see, you just imagine after 5 second, my first timer done bit is high. That's why in the second rung, you can clearly see the T4 colon 0 slash done bit become high. That's why my normally closed switch converted to the normally open switch. It changes their state. That's why my output is become low, right? Initially my output is on for the 5 second, and after 5 second my output is low. And for the counting of that 5 second of time, you can see my second timer is a start counting, because my second timer done bit is connected, my second timer is connected to the first timer done bit, right? I think the procedure is clear to you. So after 5 seconds, my second timer is provide the done bit, and you can see in the third rung, the T4 colon 1 slash done bit is connected in the NC switch. So my NC switch is connected to the NO, it changes their state to NC to NO. That's why my first timer is again resetted, and it again start with the counting for the 5 second, right? So these changes happen in the just fraction of second. That's why means my second timer reset my first timer and again start my first timer, right? Because my start button is in on state, right? Getting my point? In this case, you can see my output, that is O colon 0 slash 0, is continuously blinking for the 5 second. It will become high for the 5 second, then it will low for the 5 second, or you can say it is on for the 5 second and off for the 5 second, then again on for the 5 second and again off for the 5 second, and this process is continue because my both timer reset each other continuously after 5 seconds, and this process is stop only and only when I press the stop button. You can see my stop button is connected to the I colon 0 slash 1, and when I press the stop button, my binary output goes 0, and when the binary output goes 0, my output goes 0 because my output is connected to the binary input. And the same time, when the binary output goes 0, my first timer is also doesn't get supply and it also goes to the 0. And if the first timer goes 0, as you can see, the second timer is also goes 0 because second timer is connected to the first timer done bit, right? So this process is clear, I guess. I'm again repeating this process because this is very important to understand how my T-on timer is used and how we connect the interconnection between the timers with the switching, right? See, in this case, in this example, we have to make our output blink for the 5 second on and 5 second off. For this, we are using two timers, T4 colon 0 and T4 colon 1, right? To to read the 5 second on and to read the 5 second off. For both condition, we are using two timers. Initially, when I didn't supply to switch, that's why switch is in 0 state, that's why my output is 0, right? So when I press my input switch, the input switch is I colon 0 slash 0. When I press my input switch, my binary output goes high, and you can see the binary address is connected to the output and the first timer, T4 colon 0. So when the binary output is high, my first binary output is high, the output goes on, and the same time my timer start counting from 0 to 5 second, right? So it counts the T on time, right? In that time my output is on, right? After 5 second my done bit is goes 0, right? So T4 colon 0 slash done bit goes 0, that of my output, right? Because of T4 colon 0 slash done bit, my output goes off, and the same time my second timer start counting for the 5 second, and the second timer counts the T of time, right? But you can see here very carefully, the second timer done bit is connected to the first timer, right? In the input side, you can see in the third rung, the T4 colon 1 slash done bit is connected to the first timer, right? So when the second timer counts the 5 second, after 5 second the done bit will be high. So if the done bit will be high, means in the third rung, the normally closed switch changes their state to normally open switch. That's why my first timer get resetted, right? If first timer is resetted, means the first timer done bit goes to 0. In the same time, you can see the T4 colon 0 slash done bit in the fourth rung is connected to the second timer, so that also goes to the 0, and the same time my second timer is also resetted, right? So with one changes, with one interconnection, I am just resetting my board timer because of continue operation of blinking. Getting my point? So I guess this process is clear to you, right? So to understand this, the timer procedure, let's take another example. In this example, suppose There is a machine with large steel shaft supported by the bearing. The shaft is coupled to a large electric motor. The bearing need lubrication, which is supplied by an oil pump driven by a small electric motor. And the operation of this setup is followed by the following step. In the first step, suppose to start the machine, the operator turns the switch on. Before the shaft start to turn, the bearing are supplied by the oil by the pump for the 10 seconds. And the next step, the bearing also receive oil when the machine is running, and when the operator turns off the switch to stop the machine, the oil pump continues the supply oil for the 5 seconds. Total running time is 120 seconds. The motor is shut down and the pilot light is turned on to indicate the filter, and the oil needs to be changed. So this is my procedure, uh, and for this we have to make our ladder logic program. So you can see in the diagram, my T on and T off timer is connected to the switch. So when I press the switch, my enable bit is on for the T on timer, and my enable bit and done bit both are on for the T off timer. As you can see in the third rung, the T off timer done bit is connected to the pump. So my pump is start counting or start giving lubrications, right? And my first timer, that is T on timer, start counting from the 0 to the preset value. So after 10 seconds, my first timer, that is T on timer done bit, will be high. So after 10 seconds, my motor is on. As per my requirement, first my lubrication pump is on, and after 10 seconds, my motor will on, right? So this process is clear. And after that, this process is continue, and when I press my stop button, when I press again the start button, initially what happens, you can see when I press the again the switch, input switch, my motor goes off and my lubrication pump again start counting from 0 to 15. So it supplied the lubrications till now, and you can see the pump output is connected to the retentive on delay timer. You can see the retentive on delay timer start counting when the initially when the switch is start, right? So it start counting 120 seconds. If 120 second is there, my motor will be off, right? So it is clear, I guess. This process is clear. First, initially lubrication pump is on, then motor is on for the 10 seconds. If both are running for the 120 seconds, my motor will be off, right? So this process is clear, I guess. I am using this example because in these case, all the three timers are used: T on timer, T off timer, and retentive on delay timer, right? I am again giving the brief idea about all the three timers. See, in the T on timer, when I giving supply to the T on timer, my enable bit is high and my timer TT bit is also high, and it start counting from 0 to the preset value. And after that, when accumulator value is equals to the preset value, my done bit will be high. This is T on timer, right? What about the T off timer? When I give supply to the T off timer, its enable bit is high and its done bit is high, but its TT bit and its timer timing bit will 0 because my timer doesn't start counting. When I close the input supply, then my T off timer start counting from 0 to the preset value, and in this case, when TT is equals to high, and after that when accumulator is equals to the preset value, my done bit will be goes to 0 and my enable bit also goes to the 0 and my TT bit goes to the 0. This is my T off timer. And what about the retentive on delay timer? Retentive on delay timer procedure is similar to the T on timer. The only difference is, if in the timing period, when suppose the timer doesn't get the supply, it holds the accumulated value, right? It doesn't go for the reset, it holds the accumulated value, and when the supply is again on, it start counting from the preset value, accumulated value, right? And the procedure is same like a T on timer. When it gets supply, It's a start counting, its enable bit is on, its TT bit is on, but done bit is on after the accumulator value is equals to the preset value. Getting my point? So that's all for the timer side, for the PLC timer. So in this lecture, we cover the retentive on delay timers and the related examples related to the all the timers. In the next class, we will explore on the PLC counter programmings. Thank you. Happy learning.